Hello, humans. So we've been using the PHET waves on a string to get some ideas about frequency and wavelength. We've been using the unit hertz, which, and I suppose this is always capitalized because it was a person's last name, but a hertz is one wave every second. So if we have 4 waves per second, that would be 4 hertz. Okay? This number could be, many, many things. In sound waves, the ones that we can hear, usually we can hear 20 hertz through about 20,000 hertz. Okay, K stands for 1,000, just like kilogram is 1,000 grams. But that's not why we're here. That's important. Okay, so we've got frequency, which the unit is hertz. So frequency is how many waves per second. The wavelength is a distance. In our class, we use centimeters for this. We might use meters when we're talking about sound waves later on. We might use nanometers when we're talking about light waves that we can see. A lot of details there that we're not going to really get into today. But what I've discovered is that I've got a lot of kids who are forgetting that our independent is our X and our dependent is our Y. Now I talked to your math teachers and they said, oh yeah, they know all about that. And they mentioned ordered pairs. And they said that that the X always comes first. So if I said 2, 3, you would know that you would go across 2 and up 3. Or if we said 11, 17, you would go across 11 and up 17. So what we're going to do, we collected this data, and your data may be slightly different than these numbers because we were looking at some tiny computer screens, but the trend will be the same. So we're going to use this data that I took from a student, and we're going to make sure that we can graph that information. So just like in math class, we're going to use the ordered pairs. The independent variable, the frequency, we were able to change. And we were able to tell the computer that we wanted to model a wave with 1 hertz, and then we measured the wavelength with a ruler. And now we're going to plot a point for this one. So we're going to go across 1. Okay, let's take a look at our graph down here. So we're going to come across to 1. Okay, I'm just going to make a mark right here. I can mark all over this if I want to. And we're going to go up to 6.3. So here's 6. Now, a lot of kids were telling me today, well, I don't know where the 0.3 is. It's not labeled. Well, halfway would be 6.5. 6.3 is going to be somewhere in between these two. Let's just call that 6.3. And you know what? If it's not exactly 6.3, who cares? It's our graph. So I'm going to take my piece of paper. I don't know if this is showing up on the computer screen or not, but I've lined up my piece of paper on 1. I'm going to come across from 6.3. I'm going to put a dot. I'm going to make it a little bolder since we're working through a camera. We're going to do the next one. Oops, and this is up and down. Because remember, Y is up and down and X is across. So the next number, and you know what? I don't want to do the next one next. I'm going to do a whole number. Let's go to 2 hertz. So we're going to go 2 across and 3.15. You know what? We're getting really detailed right there. Can we just round this to 3.2? I say we can. So we're going to go across to 2. 1, 2. And we're going to come up 3.2. Well, there's 3. Halfway would be 3.5. So 3.2 is maybe right there. Come across. You know what? If it's not exactly right, for our purpose, it's close enough. I mean, look, we don't even have graph paper up here. You do have graph paper on your sheet. All right, the next one I want to do is 3 hertz. Now, what do we got to do with this 3? It's on the X, so we got to go across, and we're going to have to go up 2.1. And like I said, your number may be 2 or 1.9 or 2.2. It's close enough. It'll get us the pattern. So we're going to come across to 3. And we're going to go up 2.1. Okay. I'm going to do 2 more places on this, and then because I'm going to let you have the opportunity to do some more graphing. And remember, your numbers are probably slightly different than this anyway. But all I'm really interested in doing is finding the pattern. What happens when we change the frequency to the wavelength? Already I can see that this is an inverse relationship. If we move the frequency up, the wavelength is moving down, see? So low frequency is high wavelength. High frequency is low wavelength. That's an inverse relationship. Let's see if I can. So if I increase the frequency, I decrease the wavelength. This is an inverse relationship. Now, interestingly enough, I visited an 8th grade math class just 2 days ago, and when I showed this pattern to the math teacher, I said, what do these kids know about this graph? And he said, well, let's see. And so he pointed the graph at the kids. You know what? I'm not going to do any more of this. You know that the X is across and the Y is up and down. Here's the completed graph. So he showed the kids this chart, and he said, is this linear? And somebody said, that is not linear. And I was very pleased. And then another kid, without being asked, said, that is a negative slope. Now, admittedly, this is not linear, but it's still a negative relationship. That's where we get the, if we decrease the frequency, we increase the wavelength. That's an inverse relationship. So anytime you have a negative slope, it's an inverse relationship. This one happens to not be linear. And if you look carefully, you can tell that these don't actually fall on a pretty good curve either, but that's okay because we were making real-time measurements, and real measurements are not usually perfect, especially in middle school. All right. Finish your graph using your data. Don't worry about the data that I have, okay? It's the same pattern. Remember, go across and then up. Don't forget, a hertz is the unit. It tells us how many waves per second. 1 hertz is 1 wave per second. The hertz are the units we use to describe frequency. Wavelength is described in our class and on this activity in centimeters, could be meters or nanometers. Let's just talk about this too. A lot of kids are having trouble writing a definition for cause, but somebody in 3rd period said, it's the reason something happens. I think that was brilliant. The effect is what happens because we did something. Your independent variable is the x-axis, and in an experiment, the independent variable is the thing that you are in control of. In this experiment, you were in control of the frequency and you measured what happened to the wavelength. So the independent variable in this case is the frequency, because we could change the frequency. The dependent variable is the wavelength, because the wavelength depends on the frequency in our experiment. If we increase the frequency, we decrease the wavelength. If we decrease the frequency, we increase the wavelength. Finish your graph. Don't forget to answer this final question.